Okay, let's get started. Hello everyone, my name is Dan Selman. I'm the CTO of Clause. We've got a kind of an avalanche of information for you. So we've got, I think, 2 slides that I'm going to whiz through. Matt's going to do a demo for us, and then we'll open it up for questions. And we're going to hit you hard, so please save your questions for the end, and hopefully we'll have some time for discussion. So what I'm going to tell you about is an NPM module called Concerto. It's a standalone NPM module that's all about defining a data model or a schema. So are there any Composer users here? Anyone use Composer? Ah, lots of friendly hands. Excellent. So if you're a Composer user, you'll kind of have a bit of a head start over the others, because what we're really talking about is the Composer modeling language. And over the last couple of months, what I've done with some help from Matt is we've extracted that core capability and we've made it a standalone module, so you can use it on a web page, inside Node.js chaincode, and in a variety of other places that Matt's going to show us. So fundamentally what we're trying to do is we're trying to capture the shape of data. And Concerto is an object-oriented modeling language, so think something like XML Schema. So it can model has-a relationships, so a vehicle has a color. Is-a relationships, so a truck is a vehicle, or has a relationship to relationships. So things like an employer is related to a company. It serializes its models, or the instances of the models, natively as JSON. So it has very nice, easy to use, out-of-the-box serialization to and from JSON. And as I said, what's really unique about it is the whole stack is implemented in JavaScript. It's very small, quite efficient, and it means that you can embed it in a web browser and lots of other interesting places. And this is fairly unique as far as we know. The other thing that we do with Concerto is that we allow you to create a whole ecosystem of these models, and you can publish them to the internet, and they live on URLs. And models can reference other models, and through this mechanism, we end up with this kind of galactic soup of models where I can publish a model for, say, a vehicle, and then Matt can reference my vehicle definition in his model, et cetera, et cetera, et cetera. So you can think of a sort of an internet-scale graph of models and references, which is quite interesting. And it's particularly interesting in blockchain use cases, right, where many of these models could be coming from regulators. So, you know, in the vehicle use case, you could think of in the UK, the DVLA would have a model for what is a vehicle. And similarly, GS1 has a model for supply chain. ISDA has a model for bonds, securities, and swaps, et cetera, et cetera. So many of these models already exist, but at the moment they're quite siloed, and they use lots of different technologies to represent the models, which makes them challenging to use in blockchain projects. And then we've built a bunch of tools around this core Concerto capability. So there's an editor that you can use in Visual Studio Code, which Caroline is there. She can probably tell us much more about that editor. But we can also convert these models to and from lots of interesting sort of canonical formats. So we'll see some of those in a minute. So why would you use it? So fundamentally, blockchain is about sharing data. It's about defining the participants in a business network and agreeing what data we want to share across that network. And if anyone, most of you, I'm sure, have tried to do that, and very, very quickly you hit the, well, what format should the data be in question? And that's usually quite a complicated question, and I would like to use my format, and you would like to use your format, and then it turns out there's an industry-defined format that is close but doesn't quite meet our needs. So really, to get the benefits of blockchain, we have to agree on data formats, and that's a key purpose for Concerto. And if you've been around a bit, you'll probably know there are lots of schema languages out there. You may have invented a few yourselves, kind of ad hoc schema languages using YAML or JSON Schema or something else. We believe that Concerto is better than those for this specific use case. And I won't get into the details of exactly why we believe that, but you know, feel free to grab me afterwards. Importantly, it's programming language neutral, because we don't really know, what languages people are using at the other ends of these pipes. And in many cases, for blockchain projects, they're using multiple languages. They might be using Typescript on the front end. They might be writing Go code, that's running in Fabric. They might be writing Java code that's running in Corda. But you all want to share, a canonical data model. It gives you JSON validation. If all you want to do is check that a lump of JSON that I've just received conforms to a schema, that's kind of a one-liner. You can define your schema, and you can validate your data. And we'll see that in a minute. And then it's foundational technology for building any sort of platform tools that are configurable, via a data model. So common use cases in blockchain are things like, I've got a bunch of assets on my blockchain, and I want to expose them over a REST API. So there's two ways you could do that. You can either sort of boot up Express and start hand coding routes in Express, for all of the CRUD operations for your various assets. Or you could model your assets and then generate the REST API automatically. So having a formal data model can accelerate a lot of the kind of the boilerplate that you might otherwise write. The other thing that you can do is you can automatically generate user interface, right? Because you know what these assets are, what their properties are, the types of the properties. So you can automatically data bind the properties to user interface, which we'll see. And then, as I said, major source of bugs in most applications is kind of model drift, where the UI team thinks the model is this, and the middleware team thinks the model is that, and the database team thinks the model is something else. And we end up doing complicated model mapping as we move across the tiers, and the model mapping has bugs, and those bugs are typically quite difficult to find and costly, because you tend to find them in system tests at the very end of your development. And then finally, blockchain is about bringing organizations and people together, and so there's a communication aspect. So if your data model is, say, a YAML file or a protobuf, that obviously doesn't help communication. With Concerto, you can generate UML diagrams from these models, and then obviously put them up on a slide and have a discussion about, well, is this really the definition of a shipping crate? Are these the attributes that we want to be storing? And then finally, publish your model for reuse by others, right? Blockchain is about, people say it's a team sport, right? It's about interacting with others. So once I've defined a data model on my end, often I want to publish it for reuse by others. So that's the setup. I hope that made sense. And now Matt is going to hopefully wow us with some demos.
Thanks, Dan. We're just going to run through these really quickly. So the first thing we're going to do, just to introduce the notation to you a little bit, I'm going to, in my editor, start writing some Concerto. So we're going to define a namespace and a concept. So you'll see there's some high-level concepts, transactions, events, again, familiar to those of you that have used Composer before. So we can add an attribute to a person that is a string. And what you're seeing below is, as I build this model, the form that a form is being generated automatically below, and also the JSON serialization. So that's some of those benefits that Dan mentioned being realized already there. So we'll continue. Let's add an integer here for the age, and maybe a date time for the date of birth. We got some nice validation. That's only allows integer values. I have a drop-down field here for date time. And again, that's all serialized nicely on the bottom. I could further extend that. I think I'm going to skip through that in the interest of time. But what I could do is bring in something that already exists. So what I'm looking at now is models.accordproject.org. This is one repository that contains some pre-built models that you can reuse. There we go, they're all listed here. And the patent model is quite interesting. That diagram at the top is generated automatically using PlantUML from the definition. The definition source is listed on this page. But what we're going to do is take that URL, and I'm going to pull it into this tool, choose the patent asset, and we get a very complex form generated automatically for me, including optional repeating types and a great big serialization of that at the bottom. So that's very fast. That's pulled down across the internet and generated in real time. So that's step number one. We have a data model. We can do some things like generate REST APIs and forms automatically from that.
Yeah, that was all done client side. There was no middle tier there. That's Concerto running in the browser.
The next thing we're going to do is look at some of these other serialization formats, these other conversions. So we've got JSON Schema, Typescript, Java, XML Schema. I can download these, and I get a zip that contains, that one's a jar, this one's a zip that contains the source that I can use those in my platform of choice. Let's start with Java. We pulled this one in earlier, again, to save a little bit of time. Two things we're doing here. We're going to start from a Java object that's created by importing the definition. This is the definition that was generated by that file I just downloaded of that same patent model. Change one of the values and then serialize it to JSON, and then I'll do the opposite, go back the other way. So we round trip essentially. I read in the JSON file from disk. That's this big thing here. And then I convert that to a Java object, and I print that out. So if we run, we're going to run this one. And we can see the output from that there. Here's my instantiated object from Java with just one value changed, and here's the instance that was created from the file. What else have we got in here? Let's take a quick look at the XSD. This is the XSD output that was generated for that same Concerto file with the XSD editor. I can delve into one of these perhaps and see that in a nice editor in Eclipse, and build the diagram perhaps. And finally, just to conclude this race through those different use cases, I'm now switching my editor to VS Code. We have a nice plugin that Dan mentioned earlier for VS Code with a model defined, and what we're actually doing here is deploying that model to a Hyperledger Fabric instance. That's what this snippet does. We add the model file and we put it into the world state. And then I can send instances to that, and I'll get notified whether that's valid or not. So we have a valid instance there. If I run that once, we get a message saying that was successfully put and then eventually committed. And if let's turn off one of these required fields. So we've got some optional fields in my model. This is an instance of that model. We'll save that and run again. This time it failed, and if I check my logs, I'll see I get a validation error telling me that it was missing the required field, first name, which we just removed. So very quickly there, I hope you can see we've targeted, at least 3 different platforms that I've shown you for real. We've got a standard model that can be generated for each of those platforms, and seen some of the tooling that's available. So just to conclude, there's a whole list of resources here. I encourage you to take a look at and play with. You can install the NPM package yourself. These will all be available in the slides afterwards. And the final thing, Dan and I will be running a hands-on workshop for a set of tools that lives above Concerto for building smart legal agreements from the Accord project. within which we use Concerto models. And we're running 2 workshops, one tomorrow and one on Saturday. So it'd be great to see you all there in one of those sessions. Thank you very much.
Questions first, then applause. We might not have any answers, so save your applause. Question at the back. I think there's a microphone making its way to you. I'm exhausted just watching it.
So since Composer is not going to be carried forward in the other releases, is Concerto? I mean...
well, Composer is an open source project, so it will be carried forward based on people contributing to it.
Okay.
That's how open source works. But what we've done, sort of physically, Matt and I, right? That's how open source works. Is we've taken that core Concerto capability and we've extricated it from Composer. And I'm interested in doing more of those things. So for example, another logical one might be the Composer query language, CQL, which allows you to write SQL-style queries over these modeled entities and then compile those queries to MongoDB query language. So, based on people scratching their own itches, we might see more of Composer kind of modularized, which would allow you then to use it inside your Node.js chaincode. Any other questions? Gentleman at the front.
So I think, excuse me, Gary Singh announced the VS Code plugin, I guess, that's relatively new, if maybe not even available quite yet. Do you know much about how that is complementary or how Concerto could kind of work in conjunction with that?
So Caroline develops that plugin, so you should probably talk to her after the session. What we plan to do is have a plugin that's dedicated to just editing CTO files, so Concerto files. And thanks to the way VS Code works, that will coexist with any other plugins that you have installed. So. Question at the front?
Hi, Dan. Thank you for your presentation. My question is how, if we use Concerto for deploying it in a chain code for Fabric, how can we deal with the relations between a participant model and an asset? When we use Composer, when you implement a transaction, you could just call the getFactory function to define to get the model of a participant and just put it into the asset. But we don't have this possibility with Fabric.
Yeah, so you'll receive a transaction which you've modeled, and within that transaction you'll have a relationship which is a pointer to a participant. So you'll have to write some code, and maybe this is a good idea, this could be another potential library, which basically does a world state lookup based on the key that you've just received, and then instantiates a participant instance, based using that key.
So at the end, in Fabric, it's like a string with a key in the object. It's not really it's not a real relation.
Yeah,
on
so
Fabric level, I mean.
Yeah, essentially, your code within your chain code would be resolving those relationships.
Okay.
And maybe we could provide a library to make that easier, or you could contribute a library to make that easier.
I'd like to. Thank you.
Any more questions? So thank you for your attention. Please give it a try and send us your feedback or your pull requests. Thank you.
Thank you.